Good afternoon, and firstly, thank you to the organizers for affording me this time or this platform at this meeting. My name is Santosh Ramchuran. I'm from the Council for Scientific and Industrial Research. You've just heard my colleague as well that just left now, Mo. I'm a research group leader in bioprocessing, and I would like to basically talk to you guys about biofertilizers and biopesticides. In terms of a broader kind of nomenclature for these products, it falls under the categories of agricultural biologics. And this refers to a wide range of basically microbial products, plant extracts, insects, and other biological material. And it's been used by farmers to increase crop yields, improve plant growth and nutrient uptake, and also helps to protect them from their crops, basically from insects and fungal diseases. Now, this is not a new terminology. This has been used for centuries. I think the first reported case was around using ants used to control pests in citrus orchards. Now, the issue that has basically have come around is around chemical pesticides and the negative effects that has basically now spawned a new generation of what we call agribusiness or agricultural biologics that people are interested in. And major multinationals like your Monsantos and Syngentas and Bayers have moved very fast to adopt these technologies by buying up little companies that have been focusing on the production or in the production of these biologicals for use in agriculture. One of the reported ones in July was a major buyout by Bayer of AgriQuest in California for just over $400 million US. And this company used to basically provide pest management solutions using microbes. So let's just break this down a little further. What are these so-called agricultural biologics? So it's microorganisms isolated from soils and plants and that have beneficial effects. And it's also in terms of the products that these microbes produce in terms of controlling and enhancing growth in agriculture. Very simply put, these microbes are isolated as pure cultures and then go into biomanufacturing. They're grown up into huge at huge scales, and these are formulated into products that are readily used that can inoculate or augment various kind of crops. You also have a range of plant extracts that can be reformulated into compounds that are used, and also now what's becoming quite interesting in terms of 4IR initiatives is using industrial byproducts as some sort of biocontrol agent. Now, there's a number of these products available on the market. The range is extensive. And in terms of South Africa, unfortunately, most of these products come from international sources at the end of the day, which is a bit of a concern because with our Biodiversity Act and bringing in microbes into the country, it is a bit of a problem. However, it's not enforced in South Africa, so the guys are getting away with it. But at some point, there is going to be a backlash at the end of the day. If you look at the market segments for these products, they're broken up into 3 segments in terms of biofertilizers, biostimulants, and biocontrol agents. And your biocontrol agents are a very huge kind of segment in this, in terms of the market. And the total market value for agricultural biologics in 2015 was estimated around $5.1 billion US. It's expected to reach, that figure is wrong, from the latest reports up to around 15 to 18 million US dollars by this year. So there's huge opportunities for South Africa, and CSIR has recognized that in terms of development of their own biologics at the end of the day for use in South Africa. So let's look at the classifications of these so-called kind of market segments that we're talking about. In terms of biofertilizers, these are nutrient enhancers that are kind of used to replace that make nutrients available to plants. And in terms of the source of these kind of biofertilizers, this can be anything from plant material to microbes to animal waste that have been used. Their mode of action, primarily around nitrogen fixing, around basically making phosphates more solubilized, looking at scavenging for phosphate, and also assisting in terms of decomposition of organic matter, which helps soil mineralization. In terms of biopesticides, or these are called biocontrol agents, these are more in terms of the disease control, insect control, and plant pathogen control. And in terms of their sources, a lot comes from microbes. These include fungi and viruses, as well as plant extracts and plant growth-promoting bacteria. Their mode of action is quite simple. There's only 3 modes of action that they would basically use. And one is competitive exclusion. It's basically around fighting for the amount of nutrients that are there, or competing with the pathogen. Parasitism. And the other one is production of antibiotics. And I talk about antibiotics that are chemically synthesized. These are natural antibiotics. There's a number of microbes that produce these natural antibiotics. In terms of biostimulants, these here are called bio-yield enhancers, and these are applied to either seed or soil or growing media, and these kind of almost, in terms of the sources, are similar to the previous one, more microbes, your algal extracts, and your inorganic and synthetic products. And their mode of action basically is to increase germination, improve nutritional uptake, and to enhance basically your plant's efficiency. In some cases we have seen that they increase tolerance from abiotic stresses in terms of plants. So where am I going with this? We have seen that there's a global trend or global shift towards bio-based products. And what we have seen now, that competition exists for new value chains, that to make new value chains in terms of products from renewable feedstocks. When I talk about renewable feedstocks, I'm talking about using feedstocks from an industry that's regarded as waste and using that to convert it into a product at the end of the day. A simple example would be conversion of molasses from the sugarcane industry to valuable products like chemicals and these bio-based products. So there is a major move to shift towards replacing existing chemical products with green chemicals in the agri sector. And all this basically looks as is a paradigm shift towards what we call disruptive bio-based technologies and products that are there. And what is this basically? How you do this is by doing unique bioconversions, which simply means alternate biological pathways to produce these so-called chemicals. Okay? So at CSIR, the research approach on bio-based products has been around for the past 10 years. And we have been focusing mainly on looking at feedstocks, the conversion of these feedstocks using biochemical processes, and the production of these so-called chemicals, or for these various chemicals, from fine chemicals to specialty chemicals. And we've seen that there is a growing global and in South Africa, a market increase for agrobiologics at the end of the day. I want to say that there's no local manufacturer currently in South Africa, although there are a couple of production plants in KZN, but they are owned by by multinationals. They're not truly South African. And in terms of what the focus on bio-based products and biologicals are, it's in line with initiatives of the 4IR in terms of a circular economy and waste valorization. So, in terms of our research direction, we have basically looked at bioaugmentation. So augmentation is basically using bacteria to so-called inoculate systems to allow this bio-based kind of solutions to work at the end of the day. All bacteria are not nasty. There are some very good bacteria. You probably had some at lunch as well, in your yogurt or something like that. So don't look at it as basically nasty bacteria. So bioaugmentation is basically our research direction that we focused on. And in terms of technologies that we've developed over the past couple of years, in terms of one microorganism in particular, we have a bacillus platform. We have an in-house strain collection, something around 650 bacillus strains that we've isolated from all over South Africa, from different environments. We've created a number of products in these areas, and these are all bio-based products using bacteria that replaces products that are currently used that's coming from the chemical industry. The next focus has basically been on looking at our in-house strain collection to look at agricultural biologics and how we can kind of develop that. One of the case studies I'd like to show you is around Panama disease, where using our in-house database, we've selected a consortium of bacteria that kind of gets rid of that could kind of act against this disease. Very simply, we've selected the consortium, we've tested it in-house, And we basically made product prototypes and showed in vitro efficacy. This technology was licensed out to a company some five or 10 years ago, and is currently being sold in the South African market at the end of the day. This uses bacillus species for the simple reason of a competitive offering of bacillus species. We produce products in the form of a spore, which is dormant. So it only starts working once it actually goes into the environment and starts dividing. One becomes two, two becomes four, those kind of things. So you've got very extended shelf lives, and you have the ability to have various formats of your final product, from liquid to powder, depending on what, or granulated products, depending on the farmer's need. That's one example. The next one that we're currently doing now is around a so-called biofertilizer or bioenhancer, a stimulant. And here as well, we've got a consortium of microorganisms, bacillus-based as well, and we've been able to kind of produce these organisms at a fairly decent scale, I would say 10 liter. The trick here is to understand the metabolism of the organism and to understand how to grow it to high cell densities. This is where the CSIR comes in terms of the competitive offering. We've produced a couple of prototypes from the 10 liter scale, and we've done a few trials in wheat crops, and we saw an 85% increase in terms of crop yields for wheat. This technology currently is being scaled as we speak. It's growing at 1,000 liters at CSIR, and this technology will be licensed out in the next 30 days. And there are maize trials that are currently being conducted to see if we can have the same kind of effect. So how do we get this right, or what are we doing that's making these products get to commercialization? You can follow the traditional research and development path like the university and publish a lot of papers and take 10 or 20 years of research. We've done that in the past. Our focus now is to exploit our database. So we take the commercial approach, where we basically work directly with the SMME or the farmer in terms of a disease or a need for the product. And we go back and we screen and we select the consortium. We grow that consortium up and we do in vitro testing as quick as possible. Apologies. In the shortest time. Sorry about that. And what we do is we come out with a product prototype in a very short period of time and try and do efficacy testing before we jump in. Apologies. 90% of the time, we would require some sort of reformulation step based on the farmer's need. So you kind of do that within a year or even a year and a half and try and get all that information in there before you actually go to commercial scale. How is it possible? We have an enabling environment at CSIR which allows me to play with anything from a flask up to 1,000 liter and also do toll manufacturing. And we've put in some initiatives in place. For example, the Biomanufacturing Industry Development Center. We have an exhibition stand here, and there is a call out right now for SMMEs to come in and work together with the CSR so that we can develop technologies around the space that you can implement in your business at the end of the day. There are some flyers there, and the application process is open at the moment. So we actually provide the funding to develop the technology in-house with CSR. So I would encourage you to maybe have a look at that program and take it further. So what does this program allows us to do? Like I say, it's a focus about building a bioeconomy in South Africa using these bio-based products. We have a very distinctive competency in bioprocessing, and we're able to do these things quite rapidly. We also basically have a lot in this program around entrepreneurial development and skills transfer and training for agrochemicals. In terms of the equipment, like I mentioned, anything from a flask right up to commercial scale, up to 1,000 liters. This is not saying that we can't go further. It depends on the demand. We do in-house manufacturing up to 1,000 liters, but our hope is that sufficient traction in the market for these products will allow spin-off of these technologies for people to set up their own fermentation facilities and production facilities. We're not there yet, but we're getting there. So some of the challenges, it's not all good and well. Some of the challenges that we've seen is that normally for SMMEs in this country, the investment horizon is quite small. or short in terms of 1 year or 2 years funding. So what we've done is with the BIDC and the model that we've got at CSIR, we de-risk that investment in terms of trying to get you to a product prototype in the shortest space of time. The other aspect that we look at is in terms of developing a unique product for you. So a product that has differentiation and a unique selling point. So a unique selling point would be the example that I've given you around bacillus being sold as a spore form. It allows you a shelf life of your product for above 5 years, either in a liquid or a powder form, and the product only works when it's in the environment that it needs. So the other aspect is developing carriers, specific carriers that allow you to have that same freedom. So I am no climate change scientist, but the entire global shift towards bio-based products is happening due to the effects of climate change being real. So I think South Africa needs to move in that direction on bio-based products very soon. We see the effects of climate change faster than anybody. With that, I thank you.